Okay, welcome back everybody. So we've built a circuit here, and this is again our breadboard circuit with a resistor, a push button switch, and an LED. And we've made our loop based off of our circuit schematic from the Project Lead the Way assignment right here. And you can kind of see pictures of the physical circuit being built right here. It looks kind of similar. We brought in the black wire and the red wire to our positive and negative side. We jumped. Instead of using a jumper wire from here down to here, they connected their resistor directly into that positive side. You could do that too. But then that went down into their push button switch, and then coming out of their switch was the LED, and that went back to the negative side. I just used jumper wires to connect back and forth instead of connecting these directly. So how do we measure things now? We're gonna be measuring a couple of different things as we do this. So we're going to use our multimeter to measure. Multimeters are used in three different ways: to measure current, to measure voltage, and to measure resistance. Resistance gets measured with power off. Now I know that we put in a 330 ohm resistor, but if you wanted to measure, I could connect the positive side to one side of my resistor, the negative side to the other side of my resistor. And when I start the simulation here, it should tell me, well, I'm not measuring current. If I click on this and measure current or resistance, excuse me, it tells me that that's a 330 ohm resistor. But it doesn't work when I turn the power on. Power on actually blows up your circuit. So if you would do that in real life, you'd probably burst your LED and you'd ruin things. So current only gets measured with power off, and it's measured across, so on either side of the component, which means that it's measured in parallel with a component. Voltage is also measured in parallel with a component, and voltage gets measured, so I'm going to stop the simulation because it doesn't let me build unless it's stopped. Voltage also gets measured across a component, and it is measured with current or with power on, because if there's no voltage, you can't measure voltage. So power has to be on. Oops. So click on your item here, and I'm going to measure. Based on our circuit, it wants me to measure voltage at the diode. So if you look at my schematic here, it shows voltage being measured across or on either side. So you can imagine the one green wire on the positive side, the other green wire on the negative side, on either side of the diode. So I'm measuring voltage in parallel with my components. So you can see that on my example here that I had, and also here. So I moved my positive to the one side of my LED, and my negative is going to go to the other side of my LED. And now when I start the simulation, there's a very, very small amount of voltage that is running through with nothing on. That's just kind of what gets picked up normally in a multimeter, so we won't worry about that. But when I hold down the push button here, if I click on it and hold, there I get my voltage. The power's turned on, and now it's telling me I have 2.08 volts. So if I have 9 volts total and 2.08 volts here, I should be able to calculate what's in my resistor. But if I want to verify that, I could pull another multimeter in. So if I have 9 volts here, start simulation. If I have 9 volts here and 2.08 volts there, that means that I should have, what, 6.92 volts running through my resistor. So let's check it out. I need to stop the simulation, sorry. So let's check it out. I could measure there if I wanted to as well. So I could just bring in 2 multimeters and measure both. And if I measure now, there we go, 2.08 and 6.92 running through both of those. So you could set up multiple multimeters if you would like to measure all of your components at once. Now, multimeter also measures current. Current gets measured in line or in series, or you have to break the circuit in order to measure current. So let me just delete my lines here and show you a quick current measurement as well. This gets a little bit trickier. So what you have to do to measure current is you have to measure in series with something. So that means you complete the circuit with your multimeter. So the easiest way to do that, if I want to measure the current that's flowing through my LED, what I could do is I could remove this last jumper wire that completes the circuit here, or instead of from the the button to my LED, I could delete this wire and I could replace that with my multimeter. So this is important because if you do this in real life, if you don't connect this in series, you can blow a fuse in your multimeter and then your multimeter won't work. And if you do that, then your teacher will probably make you fix the fuse, which is kind of a pain in the butt. So I would be careful when you're doing this with current, and always ask if you're not sure. So I've now connected, and so instead of a wire going from here to here, it's going from here through my multimeter and then out here and providing power to the rest of the circuit. So I change my measurement to amperage or current, and now if I start my simulation, I could measure right here. And I know that it's 21 milliamps already, actually, because of my power supply up here. But if you have something like a parallel circuit later on, or some different circuit analysis you need to do, that is how you would measure current. And again, it's in line or in series with whatever component you're doing. And so you have to replace a component or a wire or complete the circuit with your multimeter to do that. So those are the three ways you can measure. The most important, again, though, is probably going to be your voltage. So I would just remind you, you measure across your items when you measure voltage and complete your circuit like this. And just for one more simulation, once you turn that on, then we've got, I'm measuring in current, sorry. Change that to voltage, and I've got 2.08 volts. Now, this time it says negative. All that means is I accidentally connected the positive and the negatives backwards. It's just telling me that my leads are backwards. So not a big deal. That should set you up to do the entire circuit analysis for the first circuit in this 1.2.3 activity. And from there, you should be able to expand and continue doing extra things with the rest of that activity. Good luck. Happy circuiting.